All right, so test grades. This is after the corrections were made. So, yeah, I don't know. This is insanity. I don't really understand this, but that's okay.
Does it just not with the videos for the corrections? Does it just not show the new test grade?
Does it what?
Not show the new test grade?
It does on my computer. I can see you.
I don't know, but after watching the video, it didn't change or anything.
Did you watch the whole video?
Yes.
I don't know what to say.
I don't know if it just didn't know.
Like people that did the corrections and it says 100% completed, they got 50% of the points back, just like normal. You know what I mean?
Yeah.
Okay. All right. Any questions? All right. So moving on. The next thing we're going to talk about is three-dimensional figures. 3D figures. So we need a couple important definitions before we start. First of all, a polyhedron is any 3D figure whose bases are all polygons. So that just basically means that the faces can't be curved in any way. They're just flat, and their edges are all straight line segments and not curved as well. Okay. A cross section of a 3D figure is, I guess the best way to think of it, it's like a really thin slice of the figure. Cross section of a 3D figure is a slice here. Hard to define, but let's just look at some examples. Like, for example, if I have a cylinder like this, if I have a cylinder like this, and I slice it horizontally, then a cross section of this would look like a circle, right? Just think of it as like if I cut it this way, and I look at that cross section, if I sliced it and then like opened it up and looked at the end of it, it would be circular, right? That's kind of what a cross section is. It's the 2D figure that the cut surface has a shape of. Okay, so cross sections of this depending on how you slice it, they could be a circle, right? They could be a rectangle. How could you get a rectangular cross section of a cylinder? Yeah, just slice it vertically. That makes sense, right? Everybody can visualize that. And then you could also get like an oval shape, like an elliptical shape, if you sliced it like diagonally. Does that make sense? If I sliced it diagonally like this, bless you, then the cross section would be actually like oval or elliptical. That. And there's other like weird examples. Like for example, if I just sliced off the corner of it, then the cross section might be something like this, right? If I sliced off the corner of the cylinder, this cross section would be like a parabola shape with a flat top, like that. Okay? So that's what a cross section is. You can think of it as like a really thin slice. It's really just a 2D shape, but you can think of it as like it's just a really thin slice of it. Okay? Another thing, a prism is any 3D figure consisting of two congruent parallel bases and then any cross section parallel to the base is also congruent to the base. Base is also congruent to the base. Okay. So, for example, you could have a rectangular prism, which is basically like a box shape. It would be a rectangular prism. So the top is a rectangle. The descriptive word in front, that tells you the shape of the base. Okay? So it's a rectangular top, a rectangular bottom, and they're the same size and shape. And if I took any cross section of this horizontally, it's going to be the same size rectangle as the base. Okay? So something like this would be like a triangular prism. That's a triangular prism. It has a triangular bottom, a triangular top, and any cross section that's parallel to the base is the same congruent triangle. Triangular prism. In the last chapter, we also talked about a hexagonal prism. Remember, there was a problem with that. So here's the hexagonal prism. Like your pencil is a hexagonal prism, really.
My pencil.
Hexagonal prism. So again, the word in front tells you the shape of the base. Okay? So other words associated with this, vocabulary words associated with this, are words like face. So like a face of a prism would be like one of the flat 2D surfaces that make up the prism. Those are the faces of it. So a hexagonal prism has how many faces? Yeah, 8. It has 6 sidewalls and then a top and a bottom, right? So those are the faces. Edge of a prism is like one of the line segments that makes up the prism, like that. That's an edge. And a vertex is just any corner of it. So that's a vertex of it. Okay, so those are all words that you should be familiar with. Faces, edges, vertices, okay? What else? The sidewalls of a prism are called the lateral faces. Of the prism. Okay, those are called the lateral faces of the prism. Now, keep in mind, like, you might have a prism that's not sitting on its base. That's certainly possible, in which case the lateral faces aren't going to be like the sides of it. They're going to be the faces that are perpendicular to the base. Okay, like for example, if I have a triangular prism that happens to be sitting on its side like this, right? That's a prism, but it's not sitting on its base. It's sitting on one of its lateral faces, right? The bases would be the parallel congruent triangles that is the ends of it, right? So in this case, this is a base here. And these are lateral faces. This face and back face. Okay. All right, those are lateral faces. The bases are the triangles in this case. So you have to be able to look at a prism and determine which faces are the bases and which faces are lateral faces. Okay? And it might not be sitting on its base. Just keep that in mind. Okay? Another thing about prisms is it's possible you might have a non-right prism. Okay? So a right prism is one in which the lateral faces are perpendicular to the base. A non-right prism has lateral faces which are not perpendicular to the base. Okay. This is a little bit harder to draw, but for for example, if you have suppose you have a rectangular prism that's shaped like this. This is a right rectangular prism. But suppose you have a prism that's sort of skewed a little bit. This a little bit harder to envision. Picture like one of those little pink erasers or something like that. That would be a non-right rectangular prism. Or picture like a stack of paper. Like if I have this stack of paper right here, and I have it all perfect like that, that's a right rectangular prism. But if I take the same stack of paper and I just like go like that to it, now it's a non-right rectangular prism, but you can see it's still a prism because if I take any cross section, it's still a rectangle, right? If I take any cross section that's parallel to the base, it's still the same size rectangle, but the side walls are definitely not perpendicular to the base if I hold it like this. Does that make sense? So this is a non-right rectangular prism. Okay. So now that we have some basic definitions, we can talk about other things dealing with it. So the first thing is the surface area. Surface area of any 3D figure is the sum of the areas of all faces. So for a rectangular prism, I should say for a right rectangular prism. For a right rectangular prism, surface area is the sum of the 6 rectangular faces. Okay, so if I have a rectangular prism, let's say it's labeled this, and we have length, width, and height. So this is length, width, and height. Then in this example, the surface area would be, well, if you consider this, there's actually 3 pairs of congruent rectangles. There's the top and the bottom, they're the same size. There's the front and the back, they're the same size. And then there's the 2 left and right faces, and they're the same size. So you can think of this as simplified. This would be like 2 times length times width plus 2 times width times height plus 2 times length times height, right? You have 2 rectangles whose dimensions are length times width. That's like the top and bottom, right? They have dimensions length and width. You have 2 triangles which are W by H, that would be the 2 side walls, the left and the right side walls. And then the 2 that are length times height would be the front and the back. That seems logical, right? So if they just simply gave you the dimensions of a rectangular prism, you could just apply this formula, no problem, it would work, right? Like if I have something like this. Okay, and let's say they told us that this is 3 inches, and this is 4 inches, and this is 7 inches. Then the surface area would just be 2 times 3 times 4, that's the top and bottom, plus 2 times 3 times 7, that's the front and back, plus 2 times 4 times 7, that's the left and right faces. Make sense? So this would be 2 times 12, which is 24, 2 times 21, which is 42, and 2 times 28, which is 56. So if I add these up, I get 24 and 56 is 80, 122. And what would the units be here? What's that?
Is it cube?
No?
Or is it still square?
It's still square. We're still talking about area, so it's square inches. Everybody understand so far? So that's pretty straightforward. No big deal. Sometimes they might give you a net of a prism. So the net, or a net, I'm not saying the because it's not unique, a net of a prism is a 2D figure which shows all faces of the prism. Okay, and I just said that nets are not unique. Like, for example, if I have a cube, so a cube is just a rectangular prism in which all the sides are congruent squares. Here's the cube. And I wanted to draw a net of this cube. One way to do it would be something like this. Like, it would be like cross-shaped, right? Like, you could have something like this. Right? You could take this figure, this 2D figure, and fold along the lines to get that cube, for sure, right? Everybody can envision that. But I could draw a different net of the same cube. Like, I could draw another net that looks like this. Maybe it goes like something like this. That's a net of the same cube. And they don't look alike, right? These are definitely different nets. Can everybody envision this? Like, you would just fold it along the line so that these sides would be like the side walls of the cube, and this would be the top and the bottom. So it would work. These are two different nets of the same cube. So for some problems, they might give you a net of a rectangular prism and ask you to find the surface area. That's easy too, right? Like, if I gave you a net that kind of looked like this, for example. Suppose I had something like this. As the net of the cube. Okay, and I gave you dimensions. Like I said, this was like 12 inches and 2 inches and 12 inches. That's really all you need, and you'd be able to calculate the surface area of this cube, right? Or this, it's not a cube, it's a rectangular prism. Right? Because think about it, if this is 2, then so is this. It has to be, right? And if that's 2, so is this. And if that's 12, so is this. And this is 12, and that's 2 and 12 and 2, 2 and 12 and 2, right? So just giving you those couple measurements, we can actually just sort of extrapolate that and get all the measurements. So the surface area of this thing, you can either go through it one face at a time and say, all right, this one's 2 times 12, which is 24. This one's 12 times 12, 144. This is 2 times 12, 24, 24, 144. And then just add them up. Or you could apply the formula that we talked about before. You could just take 2 times 12 times 12 plus 2 times 12 times 2 plus 2 times 12 times 2, right? There's actually 4 faces that are followed by 2 here. And then just add them up. Okay, this would end up being 2 times 144, which is 288. 2 times 24 is 48. And 2 times 24 is 48. So this is 288 plus 96. That's 384. 384. That's right. Square inches. Okay. Now in Delta Math, they give you a couple other variations of these net problems. Let me just show them to you just for a second so that you know what we're talking about here. So this is, the assignment is just called surface area of a rectangular prism. So here's one type of problem here. And if you look at it, this one's a little bit different. They're giving you, sorry?
It's already the area of the different.
Yeah, but they're not asking you to find the total surface area. They're asking you to figure out what the dimensions of the sides are. So, I mean, this is pretty easy. All you really need to do is just multiply the sides lengths together and see if, like, there's 3 combinations here. 2 by 8, 8 by 10, and 2 by 10. And just see if it corresponds to the lengths of the side, or the dimensions of the sides. Like, this would be 16, 80, and 20. Oh, that must be it. That's the answer. If I look at these 3, that doesn't work. If I look at these 3, those are big numbers. Let's take smaller numbers, like these. 10, 50, and 20. That doesn't correspond with the lengths that we actually have here. You see what I mean? So that's how you would solve this type of problem. There's one other type of problem. Let's look at a different type of problem. It's this type of problem. In this case, they're saying we have this net that's missing a side length right here. And they want to know what's that missing side length. So all you have to do is just figure out, like, the dimensions of this one, for example. Like, if I know this side is 10 and the total area is 30, what does this side have to be? 3. But then this has to be 3 as well because they match up. Like, this side and this side, if you glue this thing together, would have to go together, right? So in this case, you would just say that the area of each missing face, that's this side, would be 15, 3 times 5. And then they also ask you for the length of each missing edge. And you just say it's 3. And that's it. Okay? So those are the 2 types of questions in that section. And then there's a section where you just have to find surface area just by applying the formula. Okay? Any questions? All right. Good.
I have a quiz Wednesday.
No, not this week.